Every day, a faint radio signal arrives on Earth from farther away than any human-made object has ever traveled. It doesn't come from a cutting-edge spacecraft powered by modern artificial intelligence or advanced computing. Instead, it comes from a machine launched in 1977, an engineering marvel from another era that continues its journey through a part of the cosmos no one has ever explored firsthand. That spacecraft is Voyager 1. Nearly 5 decades after leaving Earth, Voyager 1 is still communicating across an almost unimaginable distance. Every transmission carries more than simple engineering updates. It delivers direct measurements from an environment that exists beyond the sun's protective influence, a region where no astronaut has ventured and no other active spacecraft is currently gathering data. For generations, scientists relied on computer models, telescope observations, and educated predictions to understand what lies between the stars. But Voyager 1 has changed that. Instead of observing interstellar space from afar, it is moving through it, recording conditions exactly as they exist. What makes this mission extraordinary isn't only its incredible distance from Earth, it's the realization that the universe beyond our solar system may be far more dynamic, structured, and mysterious than researchers once believed. With every new signal that reaches our planet, Voyager 1 continues to challenge long-standing assumptions and reveal pieces of a cosmic landscape humanity is only beginning to understand. And as long as that tiny spacecraft keeps whispering across the darkness, it remains our only direct witness to one of the greatest frontiers ever explored. When Voyager 1 lifted off from Earth in September 1977, its mission was surprisingly modest by today's standards. NASA designed the spacecraft to take advantage of a rare planetary alignment, allowing it to visit Jupiter and Saturn in a single mission. Engineers expected the journey to last only a few years, gathering close-up images and scientific data before the spacecraft's systems gradually shut down. Instead, Voyager 1 exceeded every expectation. After delivering groundbreaking discoveries at Jupiter and Saturn, including detailed observations of their atmospheres, moons, and magnetic environments, the spacecraft continued outward on a path that no human-made object had ever traveled. Rather than ending its mission, Voyager became humanity's first long-distance explorer of deep space. As it moved farther from the sun, the spacecraft approached one of the most important boundaries in our cosmic neighborhood, the heliosphere. This enormous bubble is created by the continuous flow of charged particles streaming outward from the sun, forming a protective region that surrounds every planet in our solar system. Inside this bubble, the sun's magnetic influence dominates the local space environment. Crossing beyond that boundary represented far more than reaching another distance milestone. It marked the point where the influence of our star begins to fade, giving way to the conditions of the wider Milky Way. In 2012, Voyager 1 officially entered interstellar space, becoming the first spacecraft in history to pass beyond the heliosphere. For the first time, scientists had an instrument operating directly inside the vast region between the stars, instead of observing it from millions or even billions of miles away. That achievement transformed Voyager from a planetary mission into something far more significant. It became humanity's only active scientific outpost in interstellar space, a lone explorer collecting information from an environment that had existed only in theory for decades. Every mile traveled beyond that boundary represents another step into territory where no spacecraft has gone before, making each transmission an opportunity to learn something entirely new about the galaxy surrounding our solar system. For decades, scientists pictured the space between stars as an immense but relatively quiet expanse, a place containing extremely thin gas, scattered particles, and weak magnetic fields spread across unimaginable distances. While researchers knew it wasn't completely empty, many expected it to be fairly uniform once a spacecraft moved beyond the sun's protective bubble. Voyager 1 has shown that reality is far more complex. As the spacecraft continued deeper into interstellar space, its instruments began recording conditions that didn't fully match earlier predictions. Instead of finding a smooth, featureless environment, Voyager detected changing plasma densities, shifting magnetic fields, and signs of ongoing activity occurring far from any planet or star. One of the most valuable instruments still operating aboard the spacecraft measures plasma waves, tiny oscillations traveling through electrically charged gas that fills interstellar space. These observations allow scientists to estimate the density and behavior of material surrounding Voyager, providing direct measurements that cannot be replicated from Earth. The data suggests that the region between stars contains invisible structures stretching across enormous distances, rather than being evenly distributed. Interstellar material appears to gather into regions with distinct characteristics, where magnetic forces and plasma interact in ways researchers are only beginning to understand. These discoveries have forced scientists to rethink long-standing models of the galactic environment. Conditions outside the heliosphere appear to change over time, indicating that interstellar space is shaped by dynamic processes rather than remaining static for millions of years. Even more remarkable is the fact that Voyager continues to detect the effects of powerful events originating within our own solar system. Massive eruptions from the sun can send shockwaves racing outward for billions of miles before eventually reaching interstellar space, where Voyager's instruments are capable of detecting their arrival. This demonstrates that our star's influence extends much farther into the galaxy than previously measured. Together, these observations paint an entirely different picture of the cosmic neighborhood surrounding our solar system. Instead of drifting through a silent, empty void, Voyager 1 is traveling through a living environment filled with invisible forces, moving plasma, and magnetic structures that constantly evolve over time. Every new measurement strengthens the same conclusion. The space between the stars is not a lifeless gap separating solar systems. It is an active frontier, rich with physical processes that scientists are only beginning to understand, and Voyager 1 remains humanity's only direct observer within this extraordinary region. As Voyager 1 pressed farther into interstellar space, scientists noticed something they hadn't anticipated. The spacecraft wasn't simply measuring random fluctuations. It was encountering patterns that hinted at a far more complicated galactic environment. Over several years, Voyager's instruments recorded changes in both plasma density and magnetic field strength that challenged existing models. Instead of remaining relatively constant, these values shifted in ways suggesting the spacecraft was moving through regions with different physical properties. One explanation attracting scientific interest is that our solar system may currently be traveling through material left behind by ancient stellar events. Long before the sun and its planets formed, massive stars lived, evolved, and eventually released enormous amounts of gas and magnetic energy into the galaxy. Those remnants can persist for millions of years, slowly drifting through interstellar space and creating enormous clouds of energized material. If Voyager is passing through one of these ancient structures, it offers researchers a rare opportunity to study the lasting fingerprints of events that occurred long before humanity, or even our solar system, existed. This possibility carries important implications. It suggests that the environment surrounding our solar system isn't permanent or uniform. Instead, as the sun orbits the center of the Milky Way, it continuously moves through different regions of the galaxy, each with its own magnetic fields, particle densities, and physical conditions. That means the protective heliosphere surrounding our solar system may also change over time. As it encounters different interstellar environments, its size, shape, and ability to shield the planets from incoming cosmic radiation could vary in ways scientists are still working to understand. These findings raise entirely new questions. Has Earth's cosmic environment remained constant throughout geological history? Could changes in the surrounding interstellar medium influence the amount of high-energy radiation reaching our solar system? And how often does our planetary neighborhood pass through regions shaped by the remains of long-dead stars? At this stage, researchers are careful not to draw final conclusions. Additional observations and future missions will be needed to fully understand what Voyager is detecting. Even so, the spacecraft has already revealed something remarkable. The galaxy is not simply a collection of isolated stars separated by empty space. It is an interconnected environment, shaped by countless ancient events, whose influence can still be measured today. Every new transmission from Voyager 1 adds another piece to that puzzle, helping scientists reconstruct the hidden history of our galactic neighborhood, one observation at a time. While Voyager 1 continues to make historic discoveries, another story is unfolding behind the scenes, one that is just as remarkable. Every new scientific breakthrough depends on a dedicated team of engineers working tirelessly to keep a spacecraft from the 1970s operating far beyond its original design life. Voyager 1 was never intended to function for nearly 50 years. Like every spacecraft, it relies on a finite source of electrical power. Instead of solar panels, which would be ineffective so far from the sun, Voyager uses radioisotope thermoelectric generators that convert heat from decaying plutonium into electricity. It's an incredibly reliable system, but it produces a little less power every year. That steady decline forces mission controllers to make increasingly difficult choices. Every instrument, heater, and onboard computer consumes precious electricity. To preserve the spacecraft's most valuable scientific capabilities, engineers have gradually powered down systems that once played essential roles during Voyager's encounters with Jupiter and Saturn. Each shutdown extends the mission, but it also means losing another unique source of scientific information forever. Communication presents an equally daunting challenge. Voyager 1 is now so distant that even a radio signal traveling at the speed of light takes nearly an entire day to reach the spacecraft. After Voyager responds, another day passes before that reply arrives back on Earth. A simple exchange of information that once took seconds now requires almost 2 full days. That delay changes the way engineers operate the mission. There is no joystick, no real-time control, and no opportunity to react instantly if something unexpected happens. Every command must be carefully planned, thoroughly tested, and transmitted with the understanding that correcting even a small mistake could take several more days. Adding to the difficulty, many of Voyager's systems have been operating continuously since the late 1970s. Components have endured decades of intense radiation, extreme cold, and constant exposure to the harsh conditions of deep space. Some thrusters responsible for keeping the spacecraft properly oriented have shown signs of wear after decades of use, leaving engineers with fewer backup options than ever before. In engineering terms, redundancy is disappearing. Systems that once had backups are now relying on single remaining components, meaning there is little room for unexpected failures. Yet despite these extraordinary challenges, Voyager 1 continues to perform one of the most demanding scientific missions in history. Week after week, its faint signal reaches Earth carrying fresh data from interstellar space. Each successful transmission is a testament not only to the spacecraft's extraordinary design, but also to the ingenuity of the engineers who continue finding creative ways to keep this historic explorer alive. With every additional month of operation, Voyager proves that determination, careful planning, and innovative engineering can extend a mission far beyond what anyone believed possible when it first left Earth nearly half a century ago. Keeping Voyager 1 alive is no longer about maintaining a spacecraft, it's about carefully managing every remaining watt of power. As the probe travels farther into interstellar space, its energy supply continues to decline, forcing engineers to think creatively about how to preserve the mission for as long as possible. Rather than accepting an immediate end, NASA has developed new strategies to stretch the spacecraft's remaining lifespan. These plans focus on reducing power consumption while protecting the instruments that continue to provide the most valuable scientific data. The challenge is far from simple. Every onboard system is connected to another. Turning off one component may save electricity, but it can also affect temperatures, communications, or the operation of nearby equipment. Engineers must carefully calculate every change before sending commands across billions of miles, knowing they won't see the results for nearly 2 days. One of the most closely watched efforts involves reorganizing how Voyager uses its remaining electrical power. By shutting down less essential systems and directing energy toward critical hardware, mission controllers hope to keep the spacecraft stable while extending the life of its remaining scientific instruments. Success could provide months or even years of additional observations from a region of space no other active spacecraft can study directly. Every extra day means more measurements of the interstellar environment, more opportunities to observe changes in magnetic fields and plasma, and more clues about the conditions surrounding our solar system as it moves through the Milky Way. Of course, the risks are significant. Voyager is operating with aging hardware that has already exceeded its expected lifetime many times over. A single unexpected malfunction could permanently end communications, leaving humanity without its only active observer in interstellar space. Even so, the engineering team continues to push forward. Every decision is guided by decades of experience, extensive testing, and a clear understanding of what is at stake. Their goal isn't simply to keep an old spacecraft alive, it's to preserve one of the most valuable scientific missions ever undertaken. If these efforts succeed, Voyager 1 will continue expanding humanity's knowledge of the galaxy, proving once again that remarkable exploration doesn't always depend on building something new. Sometimes it comes from finding one more way to keep an extraordinary mission moving forward. Today, Voyager 1 operates with only a handful of scientific instruments still active, yet the information they return is more valuable than ever. Every transmission offers a direct look at an environment that remains beyond the reach of every other functioning spacecraft, making each bit of data uniquely important to modern astronomy. One of Voyager's most critical instruments continues to measure the magnetic fields surrounding the spacecraft. Although magnetic fields are invisible, they play a fundamental role in shaping the structure of the galaxy. They influence the movement of charged particles, affect the behavior of cosmic rays, and help govern processes involved in the birth and evolution of stars. By recording these magnetic conditions directly, Voyager provides measurements that cannot be reproduced through telescopes or computer simulations alone. Scientists are able to compare real observations with theoretical models, refining their understanding of how the Milky Way functions on an enormous scale. Another key instrument monitors plasma waves, the tiny oscillations traveling through the electrically charged gas that fills interstellar space. These observations reveal changes in plasma density, allowing researchers to map the invisible materials surrounding the spacecraft. Together with magnetic field measurements, they create a detailed picture of an environment that was once understood only through indirect observations. Perhaps the greatest value of these measurements lies in their uniqueness. Unlike missions orbiting planets or studying nearby asteroids, Voyager 1 occupies a location that no other spacecraft has ever reached. If its instruments detect an unexpected phenomenon, there is currently no second probe nearby to confirm or compare the observation. Every data point becomes a one-of-a-kind scientific record. These observations are also helping scientists improve future mission planning. Engineers designing the next generation of deep space explorers can use Voyager's findings to build more accurate models of the interstellar environment, ensuring future spacecraft are better prepared for the conditions awaiting them beyond the heliosphere. For researchers, Each signal arriving from Voyager represents more than numbers on a computer screen. It is another opportunity to answer questions that have remained unresolved for decades, while often raising entirely new ones. Every successful transmission expands humanity's understanding of the galaxy just a little further. As long as Voyager 1 continues to communicate, it remains our only active scientific outpost in interstellar space. Every faint signal crossing billions of miles reminds us that even after nearly half a century, this extraordinary spacecraft is still revealing secrets from one of the most remote frontiers humanity has ever explored. Voyager 1 is doing far more than exploring distant space. It is changing the way scientists think about our own cosmic neighborhood. Every new observation helps answer one question while raising several others, reminding us that the universe is often more complex than our theories suggest. For much of modern astronomy, researchers viewed the solar system as a relatively stable environment moving through the Milky Way. Voyager's discoveries now indicate that the reality is far more dynamic. The region surrounding our solar system appears to change over time, influenced by magnetic fields, plasma clouds, and the lingering effects of ancient stellar activity. This means our sun is not traveling through a featureless galaxy. Instead, it is journeying through an ever-changing interstellar landscape, shaped by events that occurred millions of years ago. Massive stars are born, evolve, and eventually release enormous amounts of material into space. Those remnants become part of the galactic environment, creating structures that can persist long after the original stars have disappeared. Understanding these conditions is important because the heliosphere, the vast magnetic bubble surrounding our solar system, is constantly interacting with whatever lies beyond it. If the surrounding interstellar environment changes, the heliosphere may respond by expanding, contracting, or altering its shape. Those changes could influence how much high-energy cosmic radiation reaches the planets inside, including Earth. Scientists are still investigating the long-term consequences of these interactions, but Voyager has provided the first direct evidence needed to study them with confidence. Instead of relying solely on mathematical models, researchers now have real measurements collected from the very environment they are trying to understand. Perhaps Voyager's greatest lesson is a philosophical one. Time and again, history has shown that every time humanity explores a new frontier, nature proves to be more intricate than expected. The oceans, the planets, and now interstellar space have all revealed layers of complexity hidden from distant observation. Voyager 1 reminds us that exploration is not simply about traveling farther. It is about replacing assumptions with evidence. And with every faint signal arriving from beyond the sun's influence, humanity gains a clearer understanding of its place within a vast and constantly evolving galaxy. No mission lasts forever. At some point, Voyager 1's power supply will no longer be able to support its remaining systems, and the steady stream of data that has reached Earth for decades will finally come to an end. When that day arrives, humanity will lose its only active explorer operating in interstellar space. But the end of communication will not mark the end of Voyager's journey. Long after its instruments fall silent, the spacecraft will continue traveling through the Milky Way, carrying with it one of the most extraordinary stories in the history of exploration. On board remains the famous Golden Record, a collection of sounds, music, images, and greetings created to represent life on Earth. It was never expected to be found quickly, or even at all. Instead, it stands as a timeless symbol of humanity's curiosity and our desire to reach beyond the boundaries of the known. Voyager's scientific legacy will endure just as powerfully. The measurements it has gathered beyond the heliosphere will guide future research for years to come, helping scientists build better models of the interstellar medium and inspiring the design of the next generation of deep space missions. Every discovery made by future explorers will build upon the foundation that Voyager established. Perhaps its greatest achievement is not the distance it has traveled, but the perspective it has given us. What began as a mission to study two giant planets evolved into humanity's first direct investigation of the vast space between the stars. Along the way, Voyager revealed that this distant frontier is more active, more structured, and more fascinating than anyone imagined. That realization changes how we view our place in the universe. It reminds us that even after centuries of scientific progress, the greatest discoveries often begin with a simple willingness to keep exploring. Today, Voyager 1 is still moving forward, one silent mile at a time, carrying humanity's presence farther into the galaxy than any object ever created. Every faint signal that reaches Earth is more than a scientific transmission. It is proof that curiosity has no finish line. And even when that final signal eventually fades into the darkness, Voyager's greatest contribution will remain. It showed us that beyond the edge of the familiar lies a universe filled with unanswered questions, waiting for the next generation to continue the journey that this remarkable spacecraft began nearly half a century ago.